Hello. In this video, we're going to introduce garbage collection basics in Java. Garbage collection is a key feature of the Java platform, and the brain or the core intelligence behind Java's memory management techniques. And as all of you might already know or have heard about, that in Java the programmer does not have to actively manage the memory that the objects are using. He does not have to actively allocate space on the heap or on the system memory, or deallocate or clean up or reclaim that space. Hence, this space management or memory management in programming languages like C and C++ can be very tedious. And this is one of the reasons Java takes care of all of that, and which makes the programmer a lot more productive, and it's also one of the primary reasons it attracts many people to the Java platform. So now we know that you don't have to have do memory management in Java, but what does it mean? Like, how does it happen? What is this garbage collection you keep hearing about? And does that mean that there is some magic and in a program written in Java cannot leak memory? How does it internally Java take care of all these memory issues? And when do bad things happen in Java? So we're going to cover all of those topics in this video, starting with the basics of the Java heap. So when Java platform starts up, it gets a chunk of memory on the system. And the chunk of memory is divided into two parts, something called perm gen space. We'll talk about that later. And what we're primarily interested on is the Java heap. And this is what we're interested about. This is where all programs you write usually actively deal with get memory from this chunk. So now that Java has objects and classes, and you can create objects, and you can create your own class, and which is like a custom programmer written data type. So let's assume I've already written a data type called table. So I do table A equals new table. This will create, as we have already covered, a reference object of type table, and this is an instance which is of type table, and this reference points to a real table object which is in the Java memory. And then let's create another instance of the table object called table B equals new table. So B is another reference to another table object in the memory called B. Let's create a third table object called C. Again, we're creating a new table object as you can see by this new keyword. So this is another reference to some object in the memory, to this object called C. Now, all good. You created a new table A, Java created a reference, which is this instance name, and that reference points to the physical real object location in Java's heap, and that is this thing called A, and so for B, and so for C. Now I wanted to create another table object, table D. Instead of creating a new object, I say table D is equal to C. What I have done here is created a reference really, but I have not created a new object to associate it with that reference. Instead, I associated an old object's location, C's, to that object. So essentially, this will point back to this C object. See what's going on? There are 4 references and 3 objects in the memory. 2 of the references of table are pointing to the same object. Let me do something else. Let me do C equals B. Forgot the semicolons here. So at this point, this reference has been severed. We don't have this reference anymore. Now C also points to this B instance. Let's make another statement where we say D equals A. This point we have severed this link and made this D object point to the A object. So this C object is in memory, but it has nobody pointing to it. And that's what becomes a garbage collection candidate. And this is how Java determines that this object is not being used by anyone. It's just lying on the heap and using up memory. So every few minutes, depending on some configuration, Java has a garbage collection thread. A thread is basically, a program, a small program. It runs and it looks at this heap and sees any object which does not have any reference pointing to it, and just deletes them and releases that memory to the Java heap. So the user does not have to, create a new you create the object, but you don't have to do the cleanup. The cleanup automatically happens and Java does it in the most optimal way for you. So we have figured out how garbage collection happens, how the object stays on the heap in the life cycle. Let's go to some little advanced pieces of Java, the garbage collection techniques. Within the Java heap, there is 2 regions of memory: new and old. So the first time the garbage collector runs, it cleaned up this object. This is gone, and at this point these objects became a little older because they have survived one garbage collection run. As the object keep on becoming older and older, as they survive more garbage collection runs, the objects move into the old region of the Java heap. So as I told you, the way garbage collection works is by a separate program running on a thread which comes and looks at all these objects and cleans it. But you would imagine that doing that can be expensive, especially in the computer systems we have today with lots of memory, 4 GB not being uncommon, and looking through that much memory and checking it will take some time. And you don't want users to wait while the Java system is doing this cleanup for the program to execute. That will basically feel like the program has crashed or something, it's blocked. and that's not a good thing for the user. So by doing this logic, or executing this logic of generations, new and old, and some sophisticated Java garbage collection algorithms have multiple generations, new, old, and very old. So by moving the objects, what Java does is that it has 3 garbage collectors. The one focused on the new space, which runs frequently, and the other focused on the old space which does not run as frequently. So because most of the programs, the way the research has identified is that they create a lot of variables and a lot of objects, and they use it for a very short amount of time, and then they get rid of it. There are very few objects which make it into the long-term ones, and the one which become longer term, they stay around for a while. So there is no point in like trying to clean up the long-term objects as often as you would want to clean up the short-term objects. And that's how Java makes the garbage collection process faster, at the same time making it memory efficient. And that's a few Java garbage collection concepts in a nutshell.